So, hello everyone, welcome to this demo that will be about pipeline units in a software-stack resolution process. I will go through a notebook that is called Pipeline Units. You can find this notebook in ToddStation organization on GitHub under Notebooks repository, and the notebook itself is present in development directory inside Notebooks repo. This notebook corresponds also to an article that is linked in the description down below. So feel free to follow it and feel free to read through it. If you go through that article and if you follow Todd's videos, you already know that the whole resolution process is divided into three components. The very first one is resolver that corresponds to this fairy on the picture. And resolver basically resolves packages considering software stack considering Python packaging standard and walks through the dependency graph. It does not walk in the dependency graph autonomously, but rather asks another component that is called predictor, that is shown as a magician in this picture, and the resolver asks predictor how to walk through the dependency graph and how to resolve packages. Once predictor selects packages that should be resolved, then these packages go through the software stack resolution pipeline, and this pipeline scores these packages and does additional things like includes other packages in the resolution process, even outside the dependency graph, or completely removes these packages from the resolved software stack. So the whole resolution process can be seen as cooperation of the described three entities or three abstractions. In the notebook, we will try to resolve a software stack that corresponds to package TensorFlow in version 2.1.0. And we will do it in a way that instead of resolving TensorFlow in version 2.1.0, we will resolve another package that is an alternative. In Todd's terminology, it's a pseudonym to this package, and the package is Intel TensorFlow. And to complicate things even more, we will resolve into a different version. Why? It can be desired if you have an application that uses some versions of packages and you spot that there is some issue. Without changing the application itself and dependencies of this application, you can configure Todd's resolver in a way that it resolves different packages in different versions. So you can use Intel TensorFlow when you use Intel's MKL to gain some performance, and to avoid some bug, you downgrade to older TensorFlow version, even thought that you specified that you want to run TensorFlow in version 2.1. So the very first code section of this notebook imports libraries and things required. But let's go further. One of the inputs to the resolution process will be description of direct dependencies. We use format that corresponds to pip file, that is a file as generated by pipenv. And here you can find the source source of packages, that is PyPI.org. We do not use any development packages, but we use one package directly, meaning it's a direct dependency of our application, and that is TensorFlow in version 2.1.0. We also specify Python interpreter version. In this case, we are running Python 3.6. This is one input to the resolver, and it's basically the same as input to pipenv itself. But as Todd is more clever resolver and considers also the runtime environment which you run in, and also considers observations that are spotted in this runtime environment. It also accepts another input that is information about this runtime environment. So here we provide information about hardware. We do not use anything special for CPU, but you can assign specific CPU model, CPU family if you want to do resolution that would be specific for CPU. But we provide operating system information. So in this case, we are running RHEL in version 8, meaning Red Hat Enterprise Linux in version 8. As stated above in pip file, we run Python 3.6. We do not use any CUDA, and we use Linux in an architecture as stated in the notebook. Then we instantiate an abstraction that is called project, and it accepts the abstractions or entities that were described. So we have a pip file and also information about the runtime environment that is used, and this information should be used during the resolution process. Now let's continue to the next section that is called pipeline configuration. And in this section, we will create the actual pipeline configuration that will be supplied to resolver. Pipeline configuration is made out of pipeline units, and to offer functionality to come up with reconfigurable resolver that is capable of scoring packages, that is capable of removing packages from the dependency graph, or taking other paths during the resolution. There were designed different pipeline unit types. So the very first pipeline unit type is called boot. The other one is called pseudonym. Then you can find a sieve. You can find also step. You can find stride and a wrap. You can see that each of these keys corresponds to a list of pipeline units that will be called, and the names were intentionally picked in a way. They were picked because if you sort these names or types of pipeline units alphabetically, you get information how these pipeline units are called relatively. So first, there are called pipeline units of type boot, then pseudonyms, sieves, steps, strides, and finally pipeline units of type wrap. We create this pipeline configuration by parsing pipeline configuration that was provided in a YAML file or YAML format, and here you can see we have our pipeline configuration. If you follow links in the text, you will access TOTS documentation where all these pipeline units are described, their purpose, how to use them, what they accept, and how they can behave. Very briefly, we will take a look at pipeline units that are registered in this pipeline configuration. So as stated, the very first type of pipeline units that are called are pipeline units of type boot. These pipeline units are not called during the actual resolution process, but they rather are called before the resolution process is triggered. Hence the name boot. So they boot up the software stack resolution pipeline. I picked just one pipeline unit of type boot to show it, and this pipeline unit is called fully specified environment. Each time you see a pipeline unit, it's described by its name and then configurations. So these pipeline units are configurable and parameterized. You can parameterize them. This pipeline unit checks that the environment that you supplied is fully specified. That means that you supplied information about operating system name, operating system version, and also Python interpreter version. The next pipeline unit is of type pseudonym, and this pipeline unit is the first pipeline unit that is called during the actual resolution process. So here we have a pseudonym that is called alias pseudonym. That's the name of the pipeline unit. And in this case, configuration is more interesting than in case of the previous pipeline unit. So this pipeline unit is operating on a package that is called TensorFlow in version 2.1.0 coming from the PyPI org. So this is configuration when the given pipeline unit is triggered. So when the resolver encounters TensorFlow in version 2.1.0 coming from PyPI, it also considers these pseudonyms, that is Intel TensorFlow in version 2.1.0, then Intel TensorFlow in version 2.0.1. And these are basically this pipeline configuration pseudonyms for TensorFlow. That means the node in the dependency graph will be substituted with Intel TensorFlow in different versions, and these substitutions will be considered as alternatives or alternative ways during the resolution process. So here you can see it being described. This substitution is considering Python packaging. So if Intel TensorFlow would include other dependencies than TensorFlow, this is automatically taken into account. And also this can be done on direct dependencies, as will be done in our case, but these pseudonyms can be also run on transitive dependencies and will be run on transitive dependencies. Then let's move on to another pipeline unit that is of type Sieve. In this case, the pipeline unit is called solved Sieve. And what it does, it makes sure that packages that are coming to the resolution process are solved by the data aggregation pipeline, but also it makes sure that these packages do not produce any errors during the installation. So you can imagine that these packages are can cause installation errors, like setup.py is written in Python 2, but we are running interpreter in version Python 3.6. And as there could be syntax errors, or there are syntax errors, the given package is not installable into the given runtime environment. So this pipeline unit makes sure that the recommended packages are installable into the runtime environment, and that means that the application will be assembled correctly. We do not consider runtime errors in this case, but we can do so in next type of pipeline unit that is called step. So or runtime aspects of the given software stack. So in steps or step pipeline units, we score packages positively or negatively. In the supplied pipeline configuration, we have 3 steps. The very first one, called, will score Intel TensorFlow in version 2.1.0 negatively, meaning the resolver will try to find a better resolution path with a better score. As we will see, that will happen, and the resolver will find Intel TensorFlow in version 2.1.2.0.1. That is a pseudonym based on the pipeline configuration, and we statically assign score of 1. Then the last pipeline unit of type step will score protocol buffers negatively. So protocol buffers in version 3.11.1 will be scored negatively, and the resolver will try to find an alternative version of protobuf that has better score, as we will see. And the last but not least, we have a pipeline unit of type wrap. And this pipeline unit is called MKL threads wrap. It will provide some information about changes that should be done to manifests used for deploying the application, and it will provide also some additional information or in the form of justifications to the user about the stack. I haven't mentioned one pipeline unit type, that is Stride. It's not used in this demo, but feel free to follow the online documentation linked in from the notebook to see how Strides behave and how they could be used. Okay, so let's proceed. Just to recap, Todd is looking for software stacks that have high score. So what we are looking for a combination of packages in the software stack that give the higher score, the better. So that will give the highest possible score that could be run that could be found during the actual resolution process. So let's proceed to the actual resolution process. We will first instantiate predictor. There are different types of predictors, and in this demo we will use very simple predictor that is called approximating latest predictor. And what it does, it basically tries to come up with the most recent software considering the knowledge base and considering Python packages that are occurring in the software stack. So that's approximating latest predictor. Then we instantiate resolver, and we pass predictor as a parameter to this resolver. We also pass information about projects. So if you recall, we pass information about direct dependencies, about operating system version used, and about Python interpreter version. Then we also pass a parameter that is called a recommendation type. It's not actually used during the resolution process. We will have, but this parameter can tell resolver to or pipeline, additionally parameterize pipeline units. So these pipeline units come up with well-performing software stack or secure software stack, latest, stable software stack, and so on. So this recommendation type has a special meaning. Then we pass a parameter that is called limit. This limit says when to halt the resolution process. So as the resolution process, in this case stochastic, we need to have a mechanism where when we say stop the resolution process after, in this case, 10,000 software stacks resolved and scored, and give me the best candidate that you found during the resolution process. So we are interested in one software stack, the best one, and that corresponds to the count parameter. So we want to see just one software stack that is resolved with the highest score. Then there are additional parameters like beam width that restricts memory consumption of the whole resolution process. There is no limit, memory limit. There are no memory limit constraints. And then finally, we pass also pipeline configuration that was created and built. Okay, so that's about this cell. So it basically instantiates predictor, resolver. We already instantiated pipeline configuration. And now we can proceed to the actual resolution algorithm or the actual resolution. As mentioned, the resolution is stochastic. So first we assign a specific seed to random generator, and we just provide some random number to have this cell reproducible across multiple invocations. We also clear database adapter cache. So we receive more or less the same performance or the same pipeline and resolution speed across multiple pipeline invocations. So let's run the resolution process. As you see, there are supplied two additional parameters. We do not consider development dependencies, and there is no user spec explicitly submitted to be compared with. So there is no user scoring. Follow the online documentation for more details. So one of the first steps that Resolver does, it prepares so-called initial states. These initial states basically correspond to direct dependencies that are resolved. In our case, we have just TensorFlow in version 2.1.0. And then the whole resolution process is triggered and run. Then you can see a bunch of messages that are printed either by pipeline units, the resolver itself, or by predictor. So here the heavy computation is done. And one of the very first warning messages printed is that package called H5Py in version 2.5.0. That is a package that was considered during the in the dependency graph, has some installation issues in the runtime environment, so it was excluded. If you remember, that is done by our solved sieve. So it's filtering out packages that would cause that the application is not installable into the given environment. So you can see a bunch of warning messages that are printed during the resolution process. After some time, you can see that the pipeline unit finds the very first candidate that has score -0.2 and continues the resolution process. After a few 2,800 software stacks, we have a better candidate that was found during the resolution process that has a score of 0.5. And after a few iterations, we receive or we find a solution that has a score of 1.0. Then Resolver reaches the limit, that is 10,000 software stacks scored, and should also report the pipeline speed, that is something like 500 stacks per second. When we are using approximating latest resolver, or approximating latest, sorry, not the resolver but predictor. And here we can see that we found 10,000 software stacks, and all were considered. Okay, so if you recall, we wanted to resolve TensorFlow in version 2.1.0. That was the direct dependency of our application. And let's take a look at a report that was created during the resolution process. So besides other aspects like metadata and some statistics, you can also find pipeline configuration that was used. Now all the pipelines have information whether the given unit was run. So you can see which pipeline units were triggered. They are triggered lazily, so they do not need to be run all the time. And after the pipeline configuration, you can also products that were computed. So as you remember, we wanted just one product to be reported in the final report. It captures advised manifest changes. So here is a manifest change suggested, and that's basically add a new environment variable that is called OMP number threads. Its value should be 1. to the containers of your deployment config or container section of your deployment config, and that's it basically. So these are advised manifest changes. There are no advised runtime environment changes. And next, we can proceed to justifications. These are basically free text form informations that are shown to the user. So here we have a message: consider adjusting OMP number threads that is picked by Intel's MKL libraries, and make sure your application is correctly configured to get performance out of it. There is another informative message that you should make sure that there is Intel TensorFlow used in the software stack, and you should consider that your runtime environment is correctly configured. So if Intel TensorFlow is somewhere deep inside software stack and you don't know it, the recommendation engine will warn you that you should make sure your runtime environment is correctly configured, and also suggests what configuration changes you should do. Okay. So here we have information about the TensorFlow, about the direct dependencies, that is TensorFlow in version 2.1.0, that is the input to the recommendation engine. And here you can see pins down software stack, so logged requirements. The format corresponds to pip file log as produced by pipenv. But now we resolved software that has certain quality, considering the pipeline configuration that we supplied. And it has packages that are not logged to the latest, possibly considered as greatest packages in case of pipenv. But we are considering that information that was derived by pipeline units. Okay, so besides other packages, you can see that there was resolved Intel TensorFlow in version 2.0.1. If you recall, this package was scored positively. It had a score of 1. And we did not resolve TensorFlow in version 2.1.0 as pinned in the requirements file, and we did not resolve Intel TensorFlow in version 2.1 because that was penalized by pipeline units. Then you can also find information about the protobuf package that was resolved. It was resolved in version 3.11. If you recall, we had a pipeline unit that penalized the resolution of protobuf in version 3.11.1. So the resolution process found all the release considering the knowledge and packages that is aware of. Then if we take a look at score, you know that we've scored the stack positively because there's Intel TensorFlow in version 2.0.1. Then information about number of iterations that were done internally in the resolution process, and then information about the stack, so you know which packages were removed by pipeline thieves in this case, and why they are removed. So again, it's a free text information to users. As you can see, this resolution found a candidate for your application. So we are using Intel TensorFlow that has all the release and respects pipeline configuration that was stated and provided to the resolution process. Then we can try to re-trigger the resolution process again, but now we will not provide any pseudonyms and we will not provide any steps and also no wraps. So it will be more simplified pipeline configuration. Again, we create that pipeline configuration using Pipeline Builder, and we repeat the resolution process with same predictor that is called approximating latest. We get resolver instance. Again, we do the same, except we are okay with just one software stack that will be scored and reported. We again trigger the resolution process with same seed and same parameters. You can see again these warning messages, which packages were removed by the solved sieve, and this will be quite similar as we kept the solved sieve in the pipeline configuration. And here you can see reports that is shown to the user or the reader of this notebook. Again, information about pipeline and information about products. There are no advised manifest changes because there was no wrap registered and no wrap pipeline unit triggered for the resolved software stack. And if we take a look at requirements logged, we should see TensorFlow in version 2.1.0 because this resolution process is very similar to the one that is done by ppenv itself. So the stack will be kind of similar with a few nuances because the resolution algorithm is different. So with few nuances, you will see again a logged software stack with all the packages that are required to run your application, and you should be able to see TensorFlow coming from PyPI in version 2.1.0. Let's take a look at protobuf. If you recall, we in the first resolution process, we penalized resolution of protobuf in version 3.11.1. In this case, in the second resolution that was triggered, we did not penalize this package. So considering the knowledge, this package was resolved as more recent and was not penalized. So that's the notebook that shows the resolution process. And this way, I would like to thank you, and hopefully you liked it, and see you next time.